Let us talk about this problem. We are given a binary array. We need to count maximum consecutive ones in this binary array. Let's see this example. We have ones at two places. Here we have two consecutive ones and here we have 1, 1. So our output is 2. Maximum consecutive ones is 2. Let's now see this example. This is a corner case example. Here we have 4 consecutive ones. All are ones. Size of array is 4. So our output is 4. Let's see this example. In this example, we have all zeros, one more corner case. So our output is 0 because there are no ones in this array. Let's see this example array. We have 3 places where we have ones. We have 1, 1 here, 4 ones here and 2 ones here. Out of all these 3, 4 is the maximum. So our output is max 4. Now please pause this video and try to think of an approach that takes a Boolean array or binary array as input and returns count of maximum consecutive ones in it. Let us first talk about the naive solution. The idea of this naive solution is really simple. We traverse through every element. For every element, we count how many consecutive ones are there beginning with this element. And if this current count is greater than the result, we update the result. So here is C++ implementation and here is Java implementation. We are first initializing result as 0. Then we are traversing through every element. For every element, we are initializing the current count as 0. Then we are counting how many consecutive ones we have beginning with this element. If we get a 1, we increment the current count. Otherwise, we break the loop. As soon as we find a 0, we break the loop. And at the end, we check if current count is greater than result. If it is so, we update the result. And finally, we return the result. Let's see how does the solution work for this array. For this array, we will have current equal to 0 for this element because it will come out of the loop immediately. And you will have current equal to 0 only. For this element, I equal to 1, you will run this loop 3 times. The inner loop will run 3 times and you will have the count as 3. And you will update the result also as 3 because current result is 0 and current count is 3. So you will update the result as 3. When you come to this element, you will get the current count as 2 and result will remain 3 because it's smaller than 3. Now when you come to this element, your current will be 1. You will run a loop, run this inner loop only once and then you will come out as soon as you see a 0. Now when you come to 0, your current count is going to be 0. You will immediately come out of the inner loop. When you come to this one, your current count will be 2. When you come to this one, your current count will be 1. And your result got updated only once inside this array. Suppose we had more ones, suppose we had 2 more ones, then result would have been updated at the last one again. Now, what is the worst case time complexity of the solution? The worst case of the solution happens when you have all ones. When your input array contains all ones, then your inner loop will run maximum number of times. For this, it will run 4 times. For this, it will run 3 times. For this, it will run 2 times. And for this, it will run 1 time. So we are going to do theta n square work in the worst case. So an upper bound on the time complexity of the solution is big O of n square. And it requires big O of 1 auxiliary space. Now please pause this video and think of a solution that takes big O of n time, big O of 1 auxiliary space. Let's now talk about the efficient solution. This solution requires theta n time and big O of 1 auxiliary space. The idea of this solution is we traverse the array from left to right. Whenever we see a 0, we reset the current count. And whenever we see 1, we increment the current count and compare it with the result. Let's see with this example. Our current count is 0 and our result is 0. We begin from here, we see a 0, we reset the current as 0, it was anyway 0. We come here, we increment the current and we compare it with the result. Result is currently 0, so we update the result to 1. Now we come to this element, we increment the result and compare with the result. So now result becomes 2. Now we come to the next element, we see a 0. So we reset the current to 0. Now we come to 1, we increment current, we get 1. When we come here, we get current 2. When we come here, we get the current 3. And this time, current is greater than result. So we update the result to 3. Whenever we are going to increment the current, we are going to compare it with the current result also. And if current result is smaller than the current count, we increment the result. That's the simple idea. It's simply traversing the array exactly once, has the time complexity as theta n, and takes big O of 1 auxiliary space.